My name is Zak Kassas, and I am from The Ohio State University. And I'm showing some exciting work. It's a joint collaboration between my lab, the Aspen lab, and the United States Air Force, where we tried to find a backup to GPS. The idea is that today GPS interference is a big headache for aviation. We have a lot of plans to integrate unmanned aerial vehicles, whether small drones or urban air mobility, that's a fancy name for air taxi, into our national airspace. But the problem is, if someone interferes with GPS, we do not have a reliable backup system that allows us to navigate those large aircraft safely. So what we have done here is we worked with the US Air Force to prove a lot of the theory that has been developed under the NSF Career Award that I had received, among other funding organizations, especially from the Office of Naval Research and the Air Force, as I said, to showcase what we can do going from theory all the way to implementation. We worked with the Air Force to fly in 3 different regions in Southern California. They gave us their high-altitude aircraft, with which we equipped with our sensors and antennas and software. We flew there and we listened to cellular signals, and we proved that simply by listening to the cellular infrastructure, we can actually navigate the aircraft to a comparable performance to what we get from GPS. Some of the signals we listened to were more than 200 kilometers away, and we were flying at 23,000 feet. Nevertheless, we were about 5 to 10 meter level accurate simply by listening to cellular signals. Thank you to the NSF for believing in this work and for funding it. And thank you for your interest in how to make our skies safer.